Our next problem is square root of 1 minus cos A divided by 1 plus cos A should be equated to sin A by 1 plus cos A. This is the extension of the previous problem. We need to prove in different way. The question is same, but we need to prove it into different way. Consider LHS. So while considering LHS, take the rationalizing factor. 1 minus cos A by 1 plus cos A is the given thing, and you want to rationalize with by seeing the RHS, you can see 1 plus cos A is in denominator. So multiply 1 plus cos A in numerator and 1 plus cos A in denominator, which is equal to square root of, in top we have 1 minus cos square A from the algebraic expression A minus B into A plus B is equal to A square minus B square, divided by, below you have 1 plus cos A whole square, so which is equal to, so in numerator we can write sin square A divided by 1 plus cos A whole square in the denominator having whole root. Take out this whole square root with square terms inside, you will have sin A by 1 plus cos A. Earlier we used to do rationalizing of denominator, and in this case we did rationalizing of the numerator and we got the RHS. Our next question is square root of 1 minus sin A divided by 1 plus sin A, which should be equated to cos A by 1 plus sin A. So it is all same as the previous one. So we have 1 plus sin A in the denominator in those two terms. So rationalize the numerator. Consider 1 minus square root of 1 minus sin A by 1 plus sin A and multiply 1 plus sin A by 1 plus sin A for the rationalizing. So you will have on the top 1 minus sin square A from algebraic expansion, divided by, below you have 1 plus sin A whole square. So 1 minus sin square A can be written as cos square A using identity. So you will have cos square A in the numerator and 1 plus sin A whole square in the denominator having a square root for the whole. Now take out the square root and squares on both, on numerator and denominator. You will have cos A divided by 1 plus sin A, hence the RHS. Our next question is 1 minus cos square A by 1 plus sin A, which should be equated to sin A. So consider LHS as usual, because LHS is having bigger expression. So here 1 minus cos square A by 1 plus sin A. So I want to convert cos square A in terms of sin. So for that I am using identity. So 1 minus sin square A divided by 1 plus sin A. Because the right hand side is having sin expression, so bring all ratios in terms of sin. Then I want to write cos square A as 1 minus sin square A. So using algebraic expansion, 1 can be written as 1 square. So 1 square minus sin square A can be written as 1 plus sin A into 1 minus sin A whole by 1 plus sin A. So 1 plus sin A gets cancelled in the numerator and denominator. So we have 1 minus sin A. By taking out the bracket, we have 1 minus 1 plus sin A. So minus 1 plus 1 gets cancelled. You will have sin A, which is RHS. Our next question is 1 by sin A plus cos A plus 1 by sin A minus cos A, which should be equated to 2 sin A divided by 1 minus 2 cos square A. So here we have two terms which are in sin and cos. So consider the left hand side, because that is having a broader expansion of sin and cos A. So consider these two, 1 by sin A plus cos A plus 1 by sin A minus cos A. Take the LCM. So here those two are different, so I can take the product of those two. sin A plus cos A into sin A minus cos A, and in top you have these two terms will be multiplied with the crossing terms, so you have sin A minus cos A plus sin A minus cos A, plus cos A. So plus cos A minus cos A gets cancelled, and below you have A plus B into A minus B. So I want to write top you have sin 2 sin A divided by, below you have sin square A minus cos square A. Observing the RHS, you have 2 sin A on the top, so that we got, and below you have 1 minus 2 cos square A, so no sin term. So we have sin term in the below here, so convert that one into cos. So 2 sin A by sin square A can be written as 1 minus cos square A, and we have another cos square A term, so which will give 2 sin A divided by 1 minus 2 cos square A, and hence the RHS. Our next problem is sin A plus cos A by sin A minus cos A plus sin A minus cos A by sin A plus cos A, which should be equated to 2 by 2 sin square A minus 1. Consider left hand side one. So you have different operators in the expression, so take the LCM. By taking LCM you have sin square A minus cos square A, because those are A minus B into A plus B terms, so I am taking A square minus B square by multiplying. So here these two terms gets multiplied with the cross terms, so you have sin A plus cos A whole square plus sin A minus cos A whole square in the numerator. So we have, if you see in the numerator you have A plus B whole square plus A minus B whole square term, which can be written as 2 into A square plus B square. From the algebraic expansions we got this. So here you will have 2 into sin square A plus cos square A divided by, I want to take sin square A as it is, but cos square A I want to convert into 1 minus sin square A using identity, which will give sin square A plus cos square A is 1, so you have 2 on the numerator, and in below you have sin square A. If you bring this minus inside, you will have minus 1 plus sin square A. So on a whole you have 2 by 2 sin square A minus 1, which is RHS. Our next question is cot A plus cosecant A minus 1 divided by cot A minus cosecant A plus 1, which should be equated to 1 plus cos A by sin A. So anyway, left hand side is having cot and cosecant terms, and right hand side is having cos and sin terms. Just convert the left hand side, take the left hand side, and cot A I can write cos A by sin A plus cosecant I can write 1 by sin A minus 1 divided by, below also we have cos A by sin A minus 1 by sin A plus 1. Take the LCM, so you have cos A plus 1 minus sin theta, sin A in the numerator, and denominator you have sin A whole divided by cos A minus 1 plus sin A whole divided by sin A in the denominator, and this sin A and this sin A gets cancelled by reciprocating the expression in the denominator. So sin A gets cancelled, you will have cos A plus 1 minus sin A divided by cos A minus 1 plus sin A in the denominator. So this is also same as the first expression which is on LHS side, but we need RHS side in terms of cos A and sin A. So here if you consider, I just rearrange these terms like cos A minus, I'll take out minus as common here, so you will have sin A minus 1 whole divided by cos A plus sin A minus 1. See these terms, A minus B by A plus B. So now I can rationalize the factors. So cos A minus sin A minus 1 by cos A plus sin A minus 1, rationalizing this with cos A minus sin A minus 1 divided by cos A minus sin A minus 1. So I just readjusted the terms like A minus B into A plus B, and I am rationalizing the denominator with cos A minus bracket sin A minus 1, because I want to take out this denominator factor. I want to convert this denominator factor into single term, so I am rationalizing that one. So you have on top you have cos A minus sin A minus 1 whole square. Okay, so A minus B whole square, and below you have cos square A. So if it is like A plus B into A minus B, so you have cos square A minus sin A minus 1 whole square. Okay, this is the expression. I want to take it to next page. So remaining thing is cos A minus sin A minus 1 whole square for the numerator, and in denominator you have cos square A minus sin A minus 1 whole square. It is in form of A square minus B square. So which will give, in numerator I want to expand, so by expanding this one you will have cos square A plus sin A minus 1 whole square minus 2 cos A into sin A minus 1. A square plus B square minus 2AB term in the numerator divided by, you have cos square A minus, if you expand this one, you will have sin square A plus 1 minus 2 sin A. So which will give, in top you have cos square A plus, I want to expand this term, so you will get a sin square A plus 1 minus 2 sin A, and expand this term also, minus 2 cos A sin A plus 2 cos A, minus 2 cos A and minus 1 you will get plus 2 cos A divided by, and below you have cos square A minus sin square A minus 1 plus 2 sin A, which is equal to, you have 1 in the numerator from this identity, 1 plus 1 2, so you have 2 minus 2 sin A plus 2 cos A and minus 2 cos A sin A in the numerator divided by, below you have cos square A minus sin square A. This minus 1 I want to write sin square A plus cos square A plus 2 sin A, because I want to cancel some terms here. So you have on the top, if you take 2 as common, you will have 1 minus sin A plus cos A minus cos A sin A divided by, below you have cos square A minus sin square A, and this one minus sin square A and minus cos square A plus 2 sin A. So minus cos square A plus cos square A you can cancel. So you have minus sin square A and minus sin square A, you will be minus 2 sin square A. You have minus 2 sin square a here, and here plus 2 sin a. So I want to take in the numerator I want to take 1 minus sin a plus here in those two terms I want to take cos a as common. So you have 1 minus sin a divided by, so below you have, if you take 2 sin a as common, so you have 1 minus sin a, because this will become 2 sin a. If you take out 2 sin a common, here you will be 1, having 1, and here in this 2 sin square a, if you take out 2 sin a common, you will have 1 sin a is the remaining thing. So if in numerator, if you see 1 minus sin a in this term and 1 minus sin a in this term, so if you bring those 1 minus sin a as common, you will have 2 into 1 minus sin a and 1 plus cos a you will get in the numerator, and denominator you have 2 into sin a into 1 minus sin a. This 1 minus sin a gets cancelled, 2 gets cancelled, so the remaining thing is 1 plus cos a by sin a, which is the RHS term. So it will be a bit complicated one, but don't get scared about the bigger expansions. So what we did, from the given expressions I converted into smaller ratios, then I have taken LCMs and I have taken rationalizing factors for the bigger terms. This is the rationalizing factor that we used, which is the biggest one among what we considered earlier. So for the whole term, for the terms, here we have 3 terms in an expression, so for that I have considered a rationalizing factor. I processed that one, then we reach the RHS. Don't get confused while expanding, while taking commons and all. I know students will make mistakes when they are expanding bigger terms. When they are working on bigger terms, they will get confused about minus, plus and all. Just take care about those minus and plus when you are rationalizing, when you are taking expansions, when you are working with algebraic expressions. Okay, our next question is 1 plus sin a divided by cosecant a minus cot a minus 1 minus sin a divided by cosecant a plus cot a, which would be equated to 2 into 1 plus cot a. Consider LHS. Seems to be a minus b and a plus b terms in the denominator for those two expressions. Take the LCM. You have cosecant square a minus cot square a. By multiplying these two, you will have that one only. So now take the factorizing terms. So you will have 1 plus sin a into cosecant a plus cot a for the first term, and minus you have 1 minus sin a into cosecant a minus cot a. So below you have a identity, so it will become 1. Take out that one and write the remaining thing and multiply these two terms. You will have cosecant a plus cot a plus sin a and cosecant a plus sin a into cot a. This is the expansion for the first term, and we have next term also, that is minus of cosecant a, and these terms will be multiplied with this one. So cosecant a minus cot a minus this minus sin a would be multiplied with cosecant a, like minus sin a cosecant a and plus sin a into cot a, because this minus sin a into minus cot a will become plus. So if you see sin a and cosecant a I can cancel, here you will get 1, and here also sin a cosecant a cancel, you will get 1. And now take out the minus in all the expressions. So cosecant a plus cot a plus 1 plus sin a into cot a can be written as cos a by sin a and this bring this minus to inside, so you will have minus cosecant A, minus of minus plus cot A, and minus of minus plus 1, and minus of plus minus sin A into cos A by sin A. This cot A I can write cos A by sin A. So sin A gets cancelled, and minus cos A and plus cos A gets cancelled. Plus cosecant A minus cosecant A gets cancelled. Only the remaining thing are cot A plus 1 plus cot A plus 1. So you will have 2 cot A plus 1, and hence the RHS. Here the main turning point is multiplying the denominators while taking LCM, and multiply properly with the numerators with the respective factors, and expanding properly, so that you should not miss out the minuses or plus in the expansions. Then you will get some cancelled terms, hence the RHS. Our next question is cos theta into cot theta divided by 1 plus sin theta, which will be equated to cosecant theta minus 1. The right hand side is in terms of cosecant theta minus 1. So let it be. First take the LHS, which is cos theta into cot theta. I can write cos theta by sin theta divided by 1 plus sin theta is the term in the denominator, which is equal to, on top you will have cos square theta divided by this sin theta will be multiplied with denominator sin theta into 1 plus sin theta, which will give cos square theta. I can write 1 minus sin square theta from the identity, and below you have sin theta into 1 plus sin theta. So here 1 minus sin square theta looking like a square minus b square. This 1 I can write 1 square. A square minus b square can be written as a plus b into a minus b. So I want to write the numerator as 1 minus sin theta into 1 plus sin theta divided by sin theta into 1 plus sin theta, which is the remaining in denominator. So 1 plus sin theta gets cancelled. So you will have 1 minus sin theta in the numerator, and in denominator you have sin theta. Split this denominator to the numerator terms. So 1 by sin theta minus sin theta by this one sin theta. So sin theta side theta gets cancelled. You will have 1 by sin theta can be written as cosecant theta, and minus remaining is 1. So that's what the RHS is.